Hello, listeners. Howdy, listeners. Welcome back to the circuit. I am Ben Bajarin.
Greetings, programs. I am Jay Goldberg.
Thanks for listening, and we appreciate all of the positive feedback on Jay's limited series, the Back to Basics, history of Broadcom, filling in for me while I was at a semiconductor vendor NDA event, which eventually I will be able to talk about, and that will be extremely exciting since it's a hot topic and everybody likes to talk about this company, both positively and negatively. Uh, so so you wrote a piece on valuing Nvidia. Should we value them as a hardware company, as a software company? And so we thought it would be fun to talk about perhaps some different ways to think about companies, namely semiconductor companies. But we're going to use a different company as a jumping off point. And should we value them just purely as they ship pieces of silicon, or is there a whole lot more to their story? So the way that I think this is interesting to just jump off on is to use Apple as a lens, because this is a wonderful debate about how do you value Apple? Do you value them as a hardware company, as a software company? I'm under no illusion that anyone would value them as a semiconductor company, nor should they. However, that is an element of their unique differentiation. But if I just lobbed the question to you at a high level, would you say Apple is valued as a hardware company?
I think that they're closer to being valued as a hardware company than a software company historically. I think they've they've slowly been inching away from that. They're I don't think they've ever really been thought of as a software company, which is a mistake because they do a lot of software. They're kind of being valued now as a services company. It's tricky. I mean, Apple's just so big. It's hard to really say what they're valued as. They're kind of in a class of their own. But for most of their history, I think they were viewed as a hardware company. They were covered by hardware analysts. Um, they're viewed as someone who makes computers and as a hardware company.
So okay, so this is how where I think this conversation gets super interesting, right? And it's related to things. So if and I know you had lots of arguments with your colleagues on the sell side and the buy side about this, as did I and Horace Horace Daydew and I were in a number of these New York banker meetings together. So if you just took a hardware look at the company and you said, okay, you are only a hardware company, then it's really hard to differentiate them then from any other company that makes smartphones and or PCs. And I remember like the broad view on the street was just Apple's going to be disrupted at any given time by the next lowest priced competitor, because all people care about is price. And so if somebody comes in and has an amazing phone that can do all these things, run an Android at $600, Apple's screwed. Like that was for the long time this view. And my argument was always, look, uh, Apple has never had to sell the lowest priced product. And here's why: it's because they have an exclusive on their operating systems. And so if you wanted to just value them as a hardware company, then start and say, okay, let's start with the base value model of other hardware companies, but then change your model to account for the increase in price that they can sell. Let's say it's $200 or it's $300 or it's $400 in because of their proprietary software that now gives them that high SP, that price advantage, as well as that moat. And so if you were going to try to model a software side, I would just say you do it above that baseline of other hardware companies where, yes, if they ran Windows, they would have to sell low priced computers. There's a buffer above that. Again, to find the number, it could vary, but that's where my argument was always recognize that upside in software that gives them the ASP higher than if they just ran the same software as somebody else.
Yeah, I did an analysis. This is a long time ago, but I looked at a large chunk of retail data, all the laptops being sold one year, and the average price of a MacBook was $1,000 higher than the average price of a Windows PC being sold. And these are, over large quantities, right? And so, I mean, $1,000, it's a $1,600 computer versus a $500 computer. And this was even before Apple Silicon and this is years ago. So just having that their own operating system was hugely value additive, a huge difference. You could just see that. Like you go to the store, you can buy lots of perfectly good performative Windows laptops for 500-600 bucks. The cheapest Apple MacBook is $1,000, right? And so
Mhm.
that's a huge difference in a what people thought of as a very competitive market. The Windows side is incredibly competitive, and so Apple had a huge advantage there. And in phones you can see that advantage even more clearly. Horace and I both did analysis on this in 2009, right, where we looked at market share. Back in 2009, iPhone had just launched, and it was still single digit percentage of the cell phone market. We didn't even call it a smartphone market. It was just the cell phone market. And they had roughly 5% of the market. And so people were saying, oh, it's just a toy, it's just a little niche. But at the same time that they had 5% share of the revenue, they were already at that point consuming 90% of the operating profit of all the handset vendors. Right back then, all the handset vendors broke out operating profits by for each of their phone lines, and Apple is 90% of the industry's profit. Right there were because there were a half dozen vendors that were losing money, so it was a really messy metric where it was basically Apple and Samsung were making money and everyone else was losing money.
Mhm.
And what we saw after that was most of those other companies exited the market. BlackBerry, LG, Sharp, HTC, sort of, right? You just go down the list, and most of those companies are out of the market or greatly reduced, right? And again, it goes to the software, right? The platform effects of the iPhone and iOS, and it's just a huge differentiator for them. Again,
Hmm.
the components inside the iPhone back in 2009, the components that were inside the iPhone were the same components that anyone
Mhm.
else could buy,
Mhm.
right? It was before they had the N series, the applications processor,
Yep.
and right, and yet they were making double, triple, all the profits, infinity more profits than everyone else.
Right. Right. Yeah, no, exactly right, right, and that's why sort of my point was the way you could say, well, what's the software side valuable to them? It's what they can charge over anybody by just being different and having that software. Again, tougher to model, but that was how I always argued. Like, look, they have a higher ASP. That ASP is roughly 200 to 250 bucks more than everybody else's. That's what they get because of, but they don't sell software, which is why I think it gets people sort of confused. But you mentioned the point that I think is the most important one as we transitioned into thinking about these from semis is the platform, right? And so it's really, like people like to talk about moats. And so what is it that they have that their competition does not? And to some degree, to your point about, NVIDIA, that I always thought was interesting is that the street tends to love, I'm just gonna have to use the M word, monopolies. The street loves companies that have a grip, so much leverage on a market, and so much that others don't, that they feel like they're the short list and the winner on that short list. And that's what NVIDIA has been. They've got the vast majority of GPUs out there in the data center and really even on the client side. And that's a $40 billion business, right? On its own. So there's been all this view that nobody's going to come in and take this. And that was before, I mean, even not that size, but that was the view before CUDA. NVIDIA just made the best GPUs, and they have a whole gaming ecosystem behind them, and people just want NVIDIA. They don't want anything else. Like gamers just want NVIDIA. But then, right, CUDA, GPU came along and they launched that out. And so now there's this, even NVIDIA will tell you, like, look, we're not a silicon company, we're a platform company, right? That's the language that they like to use. And a lot of it's true. But within that view, I thought your point about, look, you could model them as software because of that, that to the degree that whether or not they sell, they're not, that's the thing that keeps that lock in. That's the thing that keeps their platform optimized and unique and fuels that cycle of their development on GPU. It is all this software.
Yeah, I wrote that piece after I had a chat with a friend of mine who works at AMD, and we got on this topic of
And he disagreed with you
no. It
highly.
was
Oh, okay,
interesting.
okay.
We got on this topic of what's going on in the AI market, and AMD versus Nvidia and GPU. And he basically admitted to me, he said, we're not even trying to go after the training market. Nvidia's got that locked. They have CUDA. and there's nothing we can do about it. We're not even going to try. We're going to go after the inference market where we have a shot. And I'm not denigrating AMD. I think they're doing great, but I actually think his comments, I took them really positively, because a lot of times companies will say, "Oh, we can take them on. We can take on this dominant company," but AMD is actually making the sensible choice to just pick their battles where they can win, rather than tilt at windmills. And I just keep hearing there's obviously lots of talk everywhere about AI and GPT and LLMs, and I've talked to, I don't know, 2 dozen investors in the last month about this, and they keep asking me, what how do I invest in this? How do I invest in AI? And there aren't a lot of great options, right? There, because it's Nvidia. Like, so much of the semiconductors powering all the advances we've seen in the last 3 months on AI is running on Nvidia silicon. And so, how do they get here? How do they build that really dominant position? Like, I don't like to say monopoly, dominant. That's my
People at
euphemism.
Nvidia will be very mad at me for using that word. I'm just I use it loosely to say someone who has leverage. I'm going to get emails. I know it, that I said that in her. But you're right though. I mean, I think the key to this is, again, really what fuels their hardware. Because again, if that didn't exist, now, and this is where, again, I think it's an interesting conversation about differentiation in actual technology. Because I'm not saying that Intel and AMD's GPUs are bad, but for a long time, NVIDIA has just been known to have the best GPUs. The software side continues to fuel that cycle, pull in that moat, and then basically standardize machine learning and a whole host of other software around CUDA and around their GPUs. And so it was a super smart move. But again, brought them so much leverage. But what's interesting to me, and you made this point about AI, is, well, one, NVIDIA has been talking about AI for such a long time. I mean, arguably longer than really anybody. So you have these other companies now saying, "Hey, we're now AI companies, right?" People in semiconductors, we're now AI. In fact, I tweeted this last week. I was like, "This era will be known as the Great Pivot, when everybody goes, if we're now an AI company, it's a pivot to AI." But NVIDIA has been saying that for a long time, and yeah, it's a growing TAM in terms of money. I don't, again, know how many more semiconductors are going to get sold to do this, but that's a whole different conversation. But there is a lot of value in the software, in the services, in that part of AI. But I find it interesting that all these other companies are now just saying this, right? Well, we're AI companies. You can't just do that, right? It's got to be the whole stack, the software, the platform, and all of that has to lead to some advantage with the technology or the architecture that these companies are doing. Or again, I just don't see them making a dent in anything that really NVIDIA has built to this point, or NVIDIA's growth story.
Yeah, I agree. It comes down to this very solid software platform that they have in CUDA, and that gives them an advantage that is to a large degree unassailable anytime soon, in the foreseeable future, right? And it's interesting to see where they're going to go with it next. I don't know if we want to how deep we want to go into Nvidia, but like, they know they have something here, and they're trying to extend this in a lot of interesting ways. They're trying to put out new other software platforms or software-esque platforms, things that range from a full-blown cloud, like what they call Omniverse.
Mm-hmm.
But I would also argue some of their interconnect solutions, where they're like NVLink.
Mm-hmm.
Those aren't exactly software, but they're verging on it, where you're pooling multiple chips. Um, they I think they've stumbled on something, and they're trying to extend it now, and it gives them a really important position.
Yeah. Well, even just like you said, the NVIDIA cloud stuff, they've got three LLMs. The two I'm remembering right off the bat is BioNemo and Nemo, that run on NVIDIA cloud. So they have some assets there, again, all trained and accelerated, best to be optimized on NVIDIA GPU. So there's a services component, right, that comes to that. But the playbook is interesting, right? Because this is the one that we kept talking about, right? A couple episodes back, we talked about, is the semiconductor growth cycle over? And so what happens when you just can't sell any more chips? We know how many chips get sold in a year, and that's not growing. You then start to figure out how to maximize more revenue from your existing customers. And that's where software, the platforms, that's where maybe services starts to come into play. And that's why I think you see everybody, not just AMD, Intel, NXP, Broadcom, they're trying to tell this software story. I think to poke at what you said, which is that view us as not just semiconductor companies, maybe view us as a little bit of a software company because it's the only way to materially change their
Yeah.
valuation.
Yeah, I agree. I mean, there's a lot of talk in semiconductor land now about software. And I think just to close out on NVIDIA a bit, I think that they offer an important lesson because, yes, today they have this big software dominance because of CUDA. But if you actually go back and look at the origin of CUDA, it had nothing to do with any of the things we're talking about, right? They were trying to solve a very specific problem back in the 90s around drivers, video drivers, and incompatibility between the CPU and the GPU and the monitors. Like that was a big thorny issue. I personally bricked a PC once because there was some incompatibility issue. Like they had a tangible problem and they solved it with software. And they actually took there was a fair amount of pushback at the time because there was a little bit of a performance hit that you would have to take from having CUDA running in the background. Um, they didn't set out to build a dominant software position. They certainly didn't set
Yeah,
out to try and monetize software. And I think
yeah,
that's important because today there's a lot of confusion in among certain semiconductor executives who say, "Oh, we're going to be a software company. We're going to sell software." And I think that's the wrong mindset, right?
right.
I actually wrote another piece about it about a week before, saying semiconductor companies all say they want to sell software, and what they're implying is they want to have software company valuation multiples. That's what they
Correct.
want. What they really
Yes.
need, though, what they need is some form of competitive advantage,
Yeah.
and that's where their focus should be. Don't worry about anything as a service. Don't worry about the acronyms or whatever building, software sales teams. What you should focus on is your core product. How do you extend something around that, possibly in the form of software that gives you a competitive differentiation?
Yeah. No, no, I totally agree. In fact, just the last point on Nvidia, I was in a small group discussion with Jensen when this was sort of all kicking off, and he's such a good storyteller because really the problem that he laid on us and trying to convince us that this was the right thing to do was simply that he made the observation that the GPU is great for more general purpose computing tasks than is used today, just on graphics. And
Right.
so his whole point was general purpose GPU computing opens up the wide realm for more and more software that should just run and be optimized on the GPU. And thus CUDA was born to make it easy to make more workloads than graphics run on GPUs. It was brilliant. I mean, and now it turns out to be even more brilliant. And you're right. I don't think he saw all of this in mind, but that was his goal. Just make the GPU do more than graphics. And boom, here we are. And he was totally right. Like it makes a ton of sense. But now we're in this conversation where there's actually a lot of stuff that's been running on the GPU that doesn't need to be running on the GPU because it's expensive and it requires a ton of power. And so now there's this unbundling conversation that I think is interesting, which goes now to some more broader points about where the software opportunities are, which I think is interesting. But you had some points on thinking about this from Qualcomm that I thought were interesting. So I'll let you launch into that example.
Yeah. So I've been thinking through this, looking at semiconductor companies through the framework of software, right? And I think there are some important examples or precursors to where the industry is heading that are worth pointing out, right? And I think the first one is Intel. Um, Intel for a long time had a dominant, near monopoly position in data center, in large part because they spent so much time and money investing in Linux, right? Right. Linux, everything in the data center runs essentially on Linux now at the lowest level, and a lot of that Linux was made possible by all the time and support that Intel engineers poured into helping it in the early days. And they didn't directly monetize Linux, but their rise in the data center can, I think, be very safely tied to the rise of Linux, right? And that was a really like I don't know how much people really recognize that. The Linux people know it. I don't know if Intel and other industry people understand it, but Intel invested in software, and that yielded them immense results. I think another good example of a company that had an adjacent software support to their chip story is Qualcomm. And for Qualcomm, the software came in the form of the wireless standards. Right? We don't exactly think of the wireless standards as software, but in some senses they are. Like if you actually uncap a wireless modem and you look at the chip inside, it looks really very messy, right? You uncap a CPU and it's somewhat elegant. There's all this repetition, there's patterns there. It looks like a very organized system. You uncap a modem and it's very heterogeneous. There's all different kinds of little weird blocks here and there because Qualcomm designed their modems in order to map to the wireless standards, right? And we can talk a lot about how important the wireless standards are to Qualcomm and their development. That's a topic for a different day. But they were able to build their chips underneath this scaffold of the wireless standards, and they've done really well with that. And I think I think if you then extend that further to where they're looking today into automotive, I think it's another good market for them, not just because their product fits the specs of what's required, but you're also going to be operating in this world of a semi-proprietary set of software. Right? I don't think there's going to be an automotive ecosystem that works on all cars. That's just not going to happen. What you're going to have instead is every auto OEM is going to have their own sort of software. Maybe there'll be some common layer underneath around Linux or whatever, but it's going to be semi-proprietary. And there'll be enough similarities, though, that Qualcomm can build on that and design chips for that. And I think, again, we're not talking about them owning software. They're not. I don't think they're going to sell software so much, but they're going to use that software ecosystem to their advantage. And that's I mean that's a good way to do it. That's another good way to do it. They don't have to be a software business. They don't have to go out and buy QDX
Totally,
or whatever.
totally. And that's why I think using this Apple example, right, which is like just back to NVIDIA, and I think this point about SEP standards for Qualcomm is a brilliant one because you're totally right. I think if more people wrestled with that as again the moat that then spurs roadmap in a connectivity company that's about to go into a lot of connected things as a part of their growth story, that's a really interesting way to model kind of the upside. But just coming back to this sort of point, which is that what does a semiconductor company have that's not just we design great processors or we design great memory stacks or we design great ASICs. It's got to be more than that. It's got to be something because your competitors can also design. And then sometimes your competitors can undercut you in price. So there has to be more to that narrative that is their moats, whether they sell it or not, right? So it's standards for Qualcomm. You're totally right about Intel. It was that there was just so much data center ecosystem software around x86, and that's still there today, which is one of the reasons why x86 is still the dominant share of the data center because it's just been built around x86.
For now.
And
For now.
that's a good conversation. But then again, same for NVIDIA right, in terms of graphics. So I like this. But now I'm going to throw this one at you because we're optimistic on RISC-V, and we think that RISC-V might have perhaps some software plays. But how does a company doing RISC-V or a company that might want to do RISC-V or again a company that's big and makes chips that wants to get in RISC-V have to then think about the software ecosystem so again they're not a commodity player in RISC-V? We're solving the RISC-V problems. Like this is our consulting. Like at the moment, Brandon, so I'm lobbing out a tough question, which we could just surface in theory. This is an interesting point about there is no software moats for that yet.
Yeah. So RISC-V is going to be tricky because inherent in RISC-V, it's the whole point of RISC-V is that it's flexible. You're not dependent on Intel. You're not dependent on ARM to tell you what you can do with your design. You can customize certain pieces of it so long as you comply to whatever the certain standards. And so what that means though is there are a lot of incompatibilities within RISC-V. Your RISC-V implementation may be different than mine, even at some important levels. And if you talk to people in the space, you hear that a lot. And I think what will matter, well, I think what will help differentiate the RISC-V companies is there. I think there's no hope of unifying RISC-V, and
Mm,
I think that's going to prove fruitless. Instead, what you do is you get very good at customizing for your customer's needs. Right? You figure out what the customer really needs, and then you hone the chip. You architect it in such a way that it really meets what they need, and that's risky. That's very risky, especially if you only have five customers to choose from, and you end up customizing for one of them, and they walk away. Um, but I think that's the future, and I think that's partly why we've seen a lot of RISC-V success in embedded in IoT, where you have a much larger number of customers. They're less demanding in terms of silicon strategy. They don't have a silicon strategy. They just want something that works for them. They're not going to, some machine tool company's not going to go out and design its own chip too much. They'll happily take what's semi-custom for them from a RISC-V vendor. As opposed to, I think that's where the next step is: can RISC-V get into the data center, where it gets trickier, because then you have that large customer problem, a large customer who, by the way, can design their own silicon if they don't like what you're showing them. So I think there is room for this. I think the RISC-V aspirants out there are going to do really well in learning how to make a a chip that looks custom to a customer, but does not require custom amount of work on your engineering task force. It's that's why I like semi-custom. Like, every customer's part, it's you customer one gets your part. It has all the things you need. Customer two gets everything that they need to their specs, but underneath the hood is really just one chip, and I've just
yeah, it's
sort
the
of
same.
blown a few
Right.
fuses, or packaged it differently or something.
Yep.
And that's the path forward. And
Yeah.
I think that's actually much easier to do on RISC-V than ARM,
Yeah.
and
No, no.
impossible to do on x86.
Correct. So let's go back to your x86 point real fast. So where does AMD fall into all of this? I mean, honestly, AMD has had a lot of success, and I don't want to downplay how good their technology has been, but a lot of their success has come from a competitor's mishaps, not being able to meet demand, needing to have a good second source, and that second source being a really quality product in Ryzen. But I go back to this point that you just said, which is how defensible is this software in the x86 ecosystem? Because if it's a weakness for Intel, there's also some weakness for AMD.
So I think on the CPU side, it's challenging. Um, they can't rely on Intel being behind on Moore's law forever. Either Intel will fix itself, or they'll go to TSMC. So it's difficult on the CPU side, right? I wrote a piece about this last month. There are a dozen companies making CPUs right now. That's a big number. I think AMD's advantage is that they actually do a lot of other things. They have a complete portfolio. They've broadly diversified now. They have GPUs, obviously. They have FPGAs coming in with via Xilinx. They have some networking stuff. It's not quite as comprehensive as NVIDIA, but it's still pretty good. And to the extent that they can tie that together, uh, they I think that will be their form of competition. I think that what they have done well, and they've talked about a lot more, is they're going to push very hard into customizing chips or semi-custom stuff. They're helping the cloud players build their chips, right? I was just thinking about it. We've talked a lot about semi-custom and roll your own stuff. I mean, that's essentially what AMD did in for the gaming consoles. They
Mm-hmm.
built custom ish GPUs for Microsoft and for Sony, and that's why they have a lock on that market. I mean, that's something they've
Yeah.
done very well. I would also disagree slightly. You were saying before NVIDIA always has better GPUs than AMD. I would say on the retail side of things, it's actually fairly competitive over the years, right? There's always every cycle that the AMD will have a part that's a little bit better in the gaming market than Nvidia. It goes back and forth. It's not never been clear dominance. I think Nvidia now has a stronger brand among consumers, but AMD is still competitive in that market. Where they've really struggled has been in in the data center. They don't really sell much GPU into the data center. And I think what's going to have to happen now is they've given up on training for the time being. There's still a very large inference market for AI. And I would argue that AMD actually has a shot at getting all that because especially now where everybody is so dependent on Nvidia, prices are going up, everything's in short supply. Uh, I think that some of the cloud vendors are going to go with AMD because they yes AMD doesn't have CUDA, but to an Amazon or an Azure that matters a little bit less because they have the software chops to bridge that gap, right? And there's been this big debate recently. Microsoft is working on an AI accelerator. Is it AMD helping them or not? I don't know. It doesn't look like it, but there's been that rumor. I Even if that one's not true, I think that is sort of the path towards AMD getting a share of the data center. But the key thing there is they're a little bit vulnerable because they don't have the software. They're going to rely much more heavily on their customers for the software side of it.
Mm-hmm.
And so that won't last forever, but I think it's a good strategy for the next few years.
Yeah. So you know what I'd be curious to see, and I think we have some indication that you will see this perhaps from AMD, maybe not Intel, but I'll tell you what I'd like to see. I would like to see AMD and Intel create chips on other architectures than x86. I would like to see them diversify their architectural portfolio and go after pockets of the market because let's just throw this out. What if there is a good slice of the data center market that is poised for ARM? ARM's the right part. I'm not saying it is. I'm just saying what if it is? Well, then why not make ARM parts if you're AMD or Intel? Or if there's a RISC-V part that makes sense as an AI accelerator, why not do like why are we so tied to x86 is my point in a world where you and I are having this conversation that software ecosystem for x86 may not be the long-term moat that everybody has depended on. You don't have to respond. I'm just throwing out this is what I'd like to see. I think it would shake things up and be super interesting.
Um, I mean, AMD is not totally new to ARM. They
No.
had an ARM CPU sort of for a
Yep.
while. I think they're open to it. I think they've actually done a fair amount of ARM work over the years. Xilinx is big ARM, does a lot of ARM
Yep.
stuff. So I think it's less alien to AMD than it is to Intel.
Agree. Agree.
And Intel, I don't know, I don't know where Intel's head is on this right now. I'm not sure that I'm not sure that they should care right now.
Well,
They
they
have a
can't
few
care
bigger
right now.
problems.
Yes. Correct.
They can't
Correct.
care right now, right? But I was a little bit disheartened when they discontinued their RISC-V stuff. Right, last year they made a big splash. They're going to invest $1 billion in supporting RISC-V, largely to get RISC-V customers into their foundry, into IFS. And then in their last cost cutting, they shut that down, and I thought that was really short sighted.
Yep.
But I
Totally.
get it. They need
They have to.
money's money.
Yep.
But then in like almost the same breath, they said, "Oh, now we're going to support ARM."
Right.
And I don't know if you know, I can't tell from the outside if was that deliberately. Did they make a choice to say to drop RISC-V to go after ARM, or were those two different business units that didn't communicate and nobody coordinated? I wasn't sure how to read that because
Yeah.
it seemed kind of short sighted to me.
I mean, my take is right. They if they believe that they're going to be the second source to TSMC for ARM companies, that's far more scale than RISC-V. And so if you have to pick one, which is going to get you more scale on your foundry, assuming that they hit foundry timelines, that's the ecosystem to support. If again we're taking a 5 year view of the world versus a 10 to 15 view of the world. And I talked to them about this. I mean, and they have it's not that they're not going to make, they'll fully support RISC-V products too. There's a handful of RISC-V companies I know even talking to, so that they can still make them. But as I'm sure you would imagine, right, it's not going to have the same scale or even at the same price per wafer as ARM if they can pull that off and actually be a second source for ARM vendors at scale.
Yeah, topic for a different day.
Okay.
I don't love that strategy.
So, all right. So let's go to the last company because you're one of the few people who have this opinion on Broadcom that they are essentially going to become a software company. So, how do you fit? Well, first I assume that means that they actually can buy VMware and that gets approved. But second, so this valuation talk of software, like how do you square that? Is that because that they've believed that their multiples better if they're positioned at that, or is there some other framework you have for Broadcom?
Yeah, I don't think Broadcom is trying to become a software company, or yeah, I don't think they're a semiconductor company. I don't think they're trying to become a software company. They're a private equity fund, and so
Okay.
they should get compared to Apollo and KKR rather than
Yeah.
Oracle, Salesforce, Qualcomm. I did not actually include them in my analysis when I was looking at Nvidia as a software stock for that reason because it's just such a different it's a very very different approach to things. Right, I actually get a lot of questions from investors. Right, there's a lot of merger arbs betting on the deal closing with VMware, and one of the concerns is some people have raised this antitrust concern. You say VMware is a networking company, is important to networking, and Broadcom has Tomahawk and has obviously an important part in networking too. Are there antitrust implications of that where
Yeah.
you know VMware is going to favor Broadcom chips? And yeah, I mean, ask that question, but like, I, I'm not sure if like the Wi-Fi team talks to the networking team at Broadcom, let alone the software company on the other side of town. So they're just going to be very independent, and there's not a lot of high level corporate strategy there, right? It's a portfolio company, right?
Mhm.
So
Well,
right,
that's the that's the framework to really wrestle with that they're a PE fund. I like that. We're gonna get emails from Broadcom. Thanks, Jay. And we're now they're gonna be pissed at us both. All right. Well, we'll wrap there. Good conversation. For our listeners, we've got some guests planned that I think will be exciting and interesting. First time we're having some guests, so stay tuned for that. And until then, we will talk to you next week.
thank you for listening.